So, welcome to this session. I'm going to be talking today about tasty topics. So the idea behind this session really is just to give you some insights into the kind of work we do at Solace in terms of helping customers solve the problems that they see. So hopefully here there'll be some tools, some techniques that you can use in your development tasks. So that's the idea really. It's not a vendor pitch. If you want a vendor pitch, we've got some great ones at our booth. Please come and visit us. So my name's Tom Fairbairn. I've been with Solace on and off now for about 4.5 years. I started off in our Singapore support team, actually helped set that up, doing technical support, so kind of production support for customers, that kind of thing. Moved back to London about 2 years ago, where I moved into the pre-sales team at Solace, so helping our customers solve the problems that they have in moving data around. So Solace is all about this idea of open data movement, so a flexible platform that enables you to move data around in any format you please without trying to tie you in to a particular solution. Okay, so a quick word from the track hosts. Please do rate the sessions. This isn't my first GOTO, but it's the first year I've been to GOTO. So your feedback really is important because obviously we want to make this material as useful to you as possible. If you do have questions and, I don't know, you're shy or you like the written word more than speaking out, please do feel free to ask questions with the app. If you want to ask questions while I'm talking, please just stick your hand up and I'll come to you. I'm quite happy to take questions as I talk rather than wait towards the end. Alternatively, if it's a more complicated question, then please wait till the end. Okay, let's get started. So, kind of the base of this talk is the idea of topics and the idea of kind of publish-subscribe systems. So, I'm hoping that most of you are aware of what publish-subscribe means in terms of a pattern for information exchange. But just to kind of level set here, give you some revision, understand exactly what I'm talking about. We're talking about exchanging information in distributed systems. Okay, so this could be applications running on different hosts, it could be on the same hosts, it could be applications running in different data centers, running globally. Okay. So one of the key features of that then is this idea of decoupling. So a failure in one application should not impact the exchange of that data other than obviously that application being unavailable. So how does that work? Well, we have a publisher who is responsible for sending data, and he publishes his data to a topic. You could call it a subject. But essentially, it's a tag, a piece of metadata that ideally describes what that data is. And that enables people who need to receive that data, our subscribers, to pick and choose exactly what information they want to receive. Now, the key feature of this is that to give us our decoupling, maybe our subscriber isn't available at any given time. Maybe there are multiple subscribers, in which case it gives us this thing called fan-out. So you may have, for instance, a lot of people using their mobile phones to update, say, stock prices. We can also have multiple publishers publishing to the same topic, right? A topic is not confined to a particular publisher. And that gives us fan-in, right? Where you have multiple producers, you may have only one subscriber listening to that data. An example of that might be some kind of big data cluster that's listening to everything that's being produced in your organization to then run some later batch analytics on it. Now, something you don't normally associate with publish-subscribe is this idea of persistence, okay, of persistence of data. Data that is resident within the publish-subscribe system until a subscriber is ready to receive that data. Normally what happens is it's kind of a live, if you're there, if you're not kind of system. But some of these publish-subscribe systems do offer you persistence. And in fact, we offer a kind of hybrid. You can opt to have both, so, and I'll talk about that in a little while. But the key here is where subscriber is registering interest in a topic. It's saying, I want to receive data of a particular type. And your publisher is then tagging data with that metadata, okay? So, let's talk about a topic then. What is a topic? Well, I've already mentioned the word tag, but actually that's a bit of a leader into this slide. If we just describe what a topic is then, it's a piece of metadata, and it's going to be a string so that it's easily understandable. Now, the temptation sometimes can be, I'm just going to label the data. I'm just going to give it a very simple tag that describes it. But there's a problem with that, in that if we have multiple subscribers, some of those subscribers may be interested in different sets of that data. If you think about your Venn diagram, where your kind of universal set is all the data that's being produced, your subscribers are going to be small circles within that Venn diagram, and some of those circles are going to overlap. So let's take this food example. Imagine we're some kind of grocery, some kind of food retailer, and we're looking for slices of things, slices of food. So we might have apple slices, and we might be tempted to just tag our apple slices data with something like food apple slices. But then if we're listening to everything that is slices, we have to make a decision if all we have is a simple tag. So what we could do is we could list every type of slice, right? So we might have apple slices and ham slices. There's a problem with that, though. We've kind of broken our decoupling, because if we now start producing peach slices, and our subscriber is interested in all types of slices, we now have to update his list. And we've broken our decoupling, right? Because an update to the producer means that we have to update the subscriber, and that's not what we want to do. Okay, well, maybe we could do a string search. That's a good idea. What we can do is we can go along to the end of the string and look for the word slices. Well, that's okay, but the problem is there, you've generated a kind of dependency on the exact structure of the tag. You now have a structured tag, effectively. It's just that you're using string searches to find that structure. And then there's another problem too. You see, you've got to do a string search, and that's going to be different in different languages. Maybe you'll be using a different language to do that. Maybe you'll be implementing that string search yourself. That leads to inconsistency. One application might do string searching in one way. One application might do string searching in a different way. That's not ideal. And there's another problem too. But before I go into that, let's just look at how we could do it. If we make our topic hierarchical, so an example over there is using a slash, a bit like a folder delimiter, that gives us more flexibility. What it enables us to do is if we have wildcarding, represented here by the asterisk or star, that means we can very easily select only slices. And we don't care what happens at the other levels of hierarchy, and that's key, because then it doesn't matter what the producers do. It doesn't matter if we add a new project like peach slices. Our topic matching will always match what we want, which is slices. So this hierarchical approach means that you can decouple what's being produced from what the subscribers are interested in. Another benefit of this is if you've got a subscriber who's only interested in peaches, might be peach slices, might be whole peaches, we can use exactly the same kind of structure. We can just look at peach only and wildcard the type, the slices, and only get peaches. And that's when that becomes really useful, is if later on, after we've implemented our topic, we want to have a completely new type of conversation going on that we never anticipated when we designed this. It's just a matter of publishing to the right topic and creating the right subscription. So the whole idea here is that a topic is not the same as a tag. If you use a hierarchical topic system with wildcarding, you get so much flexibility, and you get this true decoupling between the consumers and producers of the data and the topic structure itself. Okay, so just to ram that point home, why would I care about this? Well, it's simpler. If you're using your publish-subscribe system to do all this filtering for you, you don't have to worry about that in your application. You're not implementing string search routines, for instance. It's consistent. No matter what you're doing in your information exchange, you're always using the same pattern to select the data you're interested in, and that's your wildcard. And here's another point too. If we go back to this slide here, oops, not that one, or that one. How do I go backwards here? There we go. In the example of where we're doing, for instance, a string search, we're having to receive every single message and search through the topic. And that's really inefficient, right? You're getting all that data and throwing away lots of it. If you do the wildcard approach and you let your pub subsystem do that for you, you only get the data that you're actually interested in. And that means that your application has to do a lot less work. And in the case of, like the Internet of Things, where you have low power, for instance, gateways, talking over something like 3G, there you probably care how much information you're exchanging, and only swapping that data that's of interest is probably really very important to you. So, just quickly, let's think about the topic itself. Okay, we've got this idea of wildcards and a hierarchical topic structure. Where is this topic created? Is it created when we send the message? Is it an administered object that we have to create somewhere? Is it something we have to create on the broker, right? Do we have to say, I want the topic now, and I'm going to set up the exchange of information based on that topic? Is the topic created at the receiver? Well, how we like to do things at Solace is that actually the topic itself is just a property of the message. You create it actually on send, and it just becomes a piece of metadata on the message itself. It's not an administered object in any sense at all on the broker. What actually happens is the receiver registers interest in the topic, and he creates a subscription. So your kind of administered objects are actually subscriptions and not the topic itself. And that means that your sender is free to send any message to any destination, provided he has the permissions. What it also means is that the topic can be created on message send, and so it can be different for every single message you send. It's completely dynamic. And when we come to one of the use cases, we'll see how that can be used. All right. So much revision then, let's get into some details. Okay, data formats. Sounds pretty tedious, but hopefully this is going to become clear later. So let's imagine we're working for our funky, dynamic, open source startup, right? So, it's fairly informal. I'm Tom, I'm a magician. Well, hey. And all you need to know really is my mobile phone number to get hold of me when things go wrong. That's great. It's all working very well. And in fact, it works so well, we're taken over. We're bought out by a bigger company. But they want some structure. They want to know who you report to and who reports to you. So your data format is going to change. Okay, it's not a big problem, right? We're just checking our code, update all of our applications, everything's happy. But then you get the phone call. Turns out there's a reporting application that can't be upgraded just yet. Don't know why, could be regulatory. So we need to run these two data formats at the same time. That's a problem. Do we want to write our code so that it understands both data formats? That's one approach. But the problem with that, of course, is that you will end up with legacy code hanging around the place. maybe a bit of technical debt. Nobody can be bothered to go in and trim out that code you no longer need. Well, here's an alternative approach. First of all, let's just think about our traditional CI/CD pipeline. We can use our data format here, this is JSON. We can use that as a kind of key into what our data format is. So if we tag our source code files, in this case using Git, we can then tag them which data format that is. And then when we come to do our build, we can use that tag. And here's how we do it, right? So in this case, I'm using JSON. So we tag our class, which in JSON terms means that, for instance, with JSON, by tagging the class, we're then tagging the data format. Okay? And then what we can do is we can take our Git tag name and add it to the topic. So what we've done here is we've extracted information from our version control system and put it directly in the topic because the topic's completely dynamic. Now, what's great about that is that then, regardless of what the data format is, we automatically create our topics, and the data format is then part of that topic. So, for instance, when I send my V1 data, it will only go over that V1 topic. What's more, I've built all my code using all of that V1 tagged code. So all of my data formatting routines will understand V1. And I can run both of them in parallel because my V1 applications are never going to get my V2 data format because they've been implicitly built to understand only the format that my topic is for. It's quite a simple idea, but it's quite powerful. It enables you to be completely confident that your application is going to get the data in the format that it's expecting. Okay, so that's one idea. That's quite a neat one. I'll talk about another case study now, authorization. So if we imagine in our pub subsystem, maybe we want some people to be unable to see data that they're not supposed to see. So a good example of that is, let's say you have a mobile application and you're talking in and you're getting, for instance, an account balance. Right? And your account balance is coming over a topic, but you don't want anybody else to see your account balance. Right? Okay, so a neat use of kind of push style of technology in this case is as and when your balance is updated, we can push that update to you rather than relying on you requesting an update for your balance. Okay, so how we can do this then is we can have a separate application, this one here, what I've called subscription app, that manages your subscriptions on behalf of other applications. So let's imagine that our any app over here is out on the internet. Now the problem there is that, if I request a balance request, I don't really want him knowing which topics to talk to because he then could perhaps start subscribing to topics he's not supposed to hear. So, for instance, he might say, I know my balance updates are coming in on balance update Tom. Maybe let's see what Harry's balance update is by subscribing to balance update Harry. Okay. So what we do here is we have this separate app that is under your control, probably running in your core network. And when our internet application here, our any application connects, he sends a request on a different topic. And he says, I want to request a balance update, and I'm Tom. Our subscription app here then decides what topics any app with user Tom is able to subscribe to. Okay, so that's a bit of core business logic that you've got running in subscription app. But, and here's the clever bit, subscription app does the subscription on behalf of any app. So subscription app tells the publish subscribe system, any app is now subscribing to balance update com. Now what's key about that is that any app doesn't even know what topic he's listening to, doesn't even know what the subscription is. All he knows is that he connects to the publish subscribe system and the data starts coming towards him. So if any app tries to do something clever and tries to subscribe to something that he's not entitled to, he can't even do any subscriptions because they've all been applied for him. So that means that your authorization can be completely dynamic. If we suddenly decide that any app needs to access other data and is entitled to that, we can then start applying subscriptions on his behalf at any point during this conversation. Okay. What about monitoring then? We've got this publish-subscribe system, and we're going to be interested in what's going on there to make sure that our system is healthy, okay? So maybe there's an application there that's under really heavy load, can't cope with the messaging rate. Maybe there's somebody listening, but they're listening to far too much. They've got the volume turned up too high. How are we going to deal with that? What about somebody who's shouting too loud? They're spewing out messages all over the place and people actually aren't particularly interested in what they're saying. What about him? What's going on with him? Well, he's stuck. He's just completely stopped. Right? So there are a couple of things we need to watch out for here. We need to make sure that people aren't consuming too much resource. We need to make sure that our applications are healthy and can keep up with our messaging flow, and we need to make sure that applications haven't stopped completely. Well, here's an idea. What about if we use our publish-subscribe system to distribute that data? In the Solace world, we have a monitoring and management API, and rather than having everybody who needs that information firing against that API, why not just have a single monitoring app that listens to everything that it needs to know and then publishes that information over the pub/sub bus. And that way, anybody that needs that information can just connect in as a normal subscriber and receive that monitoring information. It's quite what I would say there is it's a case of kind of us in terms of a pub/sub system eating our own dog food, right? We're going to distribute our information by our information distribution fabric. So what you can do then is it's really very easy to attach dashboards, for instance. So, you might have somebody who wants to build a web dashboard, so you might want to do that using REST. You might have a mobile application, and maybe your operations people like to go home on the weekend, and they don't want to have to connect it. They don't want to have to come into your office, and maybe having something on their mobile phone to see what's going on is a great idea for them. And so that's it. So what we end up there with is, a very quickly moving slide. This is an example of what we can do. If you come by our stand, we'll show you this. But here's an example of where we're sending out the statistics on our publish-subscribe system, and then subscribing to that information. So for instance, we've got message rates, we've got data throughput, we've got operational status here. And in fact, any of the management information that we can produce from our platform, we publish over it in this kind of format. Okay, all right. What about another use case then? Replay. Okay, so this is quite popular in the microservices kind of approach. So in microservices, people talk about polyglot persistence. And one of the concerns there is what happens if my application fails? Do I want to have another style of database there that is going to persist my state information so that I can bootstrap myself when I restart? Well, the point is in a microservices kind of architecture, our state is really represented by what's happened on our message stream, right? So just in terms of where we are in the data flow, but also configuration information can be sent as messages. So for this, we use this idea of a queue that can subscribe to topics that are published to. So we are mixing this publish-subscribe model with kind of queuing, because our queues are becoming subscribers. And what we can do with our queue is we can subscribe to multiple topics. It's fully dynamic. You can just add subscriptions during messaging operation. So what that means in this replay of state idea is that we can create a state queue that listens to all of the information that's relevant for our application state. So it could be configuration data, and it's probably going to be our app data too, our data stream. And the point is then we have a queue that contains all of the state information, and if our application fails and needs to restart, we can simply restart and start browsing, we call it, which is to say looking at the messages on the queue without consuming them. And that way we can fully replay the whole state of the world from where we are. There's some other things we can do too. We have this idea of a last value queue, which essentially listens to what you're publishing and stores only the last message that you've published. So when we're bootstrapping, we replay our state of the world, and the last piece of information we need is how far did I get in sending my last message before I crashed? And our LVQ will hold that information for you. If this state information is time-bound, it's only useful for a certain amount of time, we can tag messages with a time to live. And so they'll then pop off the queue when they're no longer useful. So for instance, we might have a process that is doing maybe overnight batch runs, for instance. So configuration information from the previous night is of no interest. So we set our TTL to expire those messages off the queue. So, last but not least, I was talking earlier about this idea of topic dynamism and how our topics are created on the fly, and you can have a single topic per message. And this is a great example of how you can do that. It was written by a colleague of mine, actually, who presented this at ICOMP this year. Let's imagine that we are a delivery company, and we have vehicles with deliveries on them traveling around. And we want our user to be able to start up his application and discover how close the vehicle is to him. Now, we could publish updates from every single vehicle and have the application process all those messages and find the ones that are of interest. But that would entail doing a kind of geographic matching, location matching, on every single update from every vehicle. Wonder if there's something a bit more simple than that. Well, let's imagine we put the location of our vehicle in the topic. Now, the key point here is that that means that every single update from every single vehicle is in a completely new topic, and that makes use of our topic dynamism. Okay, so we've got our vehicle location in there. If we've said earlier, if we want to identify a particular vehicle, we can use our wildcards to do that. We simply say, don't care where car 21 is, I just want to know, I just want to get him. But let's think about what we can do with our wildcards then. If we match part of the location there, let's say we match the least significant digit, what that actually corresponds to is a rectangle on a map. Actually, the equator will be a square, but in most cases it's a rectangle. Because we're matching everything from, in this case, latitude 5152.015 to 20159. And similarly, we can do the same for longitude, and what that gives us is a little rectangle on the map. Well, if you think about it, all we've got to do is scan up and down the significant digits with our wildcard, and that increases and reduces the size of the rectangle that we're matching. So actually, we can match much larger rectangles. We can match a rectangle of just about any size we choose just by moving our wildcard up and down the significant digits. Okay, well that gives us rectangles, but we saw a circle earlier. How are we going to do that? Well, if anybody's familiar with Fourier theory, it turns out that any circle can be, any circular shape can be more or less approximated by successive rectangles. So all we do is add increasingly refined rectangles, and we can get just about any shape we want. So if we were to look at our circle here, you can see that we've generated these rectangular subscriptions that very closely match the circle. It's quite keen. We can do any polygon. We can get accuracy down to the meter level, because that's the accuracy of our latitude and longitude. Now, the key thing here is that for this circle, we generate the subscriptions once. Okay? We do that once. Our application is then receiving any data that matches that circle. So what that means is that now, all of a sudden, just by doing some subscription generation, we are now geographically matching in that bound there. And we will get updates for all these vehicles within that match in real time with no extra computation. So we've turned what is quite a difficult problem of having to do lots of matching on every message into something that's simply a matter of generating the right subscriptions. So that's quite powerful. How we actually do it, the actual algorithm, if you're interested, is we take the world and divide it into 4 quadrants, which match subscriptions, most significant digit in this case, and we see if our area of interest matches that particular quadrant, and if it doesn't, we throw it away. If it does, what we do is then move down our significant digits, generating our smaller subscriptions, and we just keep doing that. So we divide our quadrant up into 100 smaller quadrants and throw away those that don't match and keep those that do, and then we do that for every single one of those that do match and just keep going until we get the desired level of accuracy. Yeah, it's quite a neat little algorithm. Last point on this then is, how are we going to deploy our subscription logic? Right? Could do it via a library, right? So every application makes a call into the library and that generates the subscriptions for it. That's a bit of a pain though, because then you've got dependencies on a library and you've got different languages that you're using. Not ideal. Well, do you remember earlier I was talking about our subscription app that was used for security? Well, we can do precisely this. We can have our subscription app understand our Polygon algorithm and generate the subscriptions for us. So then what happens is, my user comes in and says, I'm interested in the information within a certain area, and tells the subscription app what that area is. Our subscription app generates the subscriptions and applies them on behalf of our user application. So as far as our user application is concerned, all he does is connect, send the area of interest, and all of a sudden he's got live real-time data streamed towards him. He's had to do no computation whatsoever. So it's incredibly lightweight. What's more, any changes we make to our subscription algorithm, we only have to apply them once. So it makes deployment really easy. If we need to scale this subscription app, we can just horizontally scale it because we're just listening on our pub sub bus. So that's really all I had in terms of use cases. We have, obviously, a lot more use cases than that, but those are kind of some of the interesting aspects of topic routing and filtering that maybe you could apply to what you're doing. This is a developer conference, so we always have to have a code snippet, right? So this is my last code snippet, and it goes something like this. If your topic is not, if your topic is not just a tag, then you get access to this topic routing and filtering facilities, like you can do this geolocation, like you can do your very simple data versioning, like you can do message replay. And that's it. Thank you very much. Hope you found that useful.